Let's get into ThinkCentral lesson 310 for homework. I think we're talking about dividing fractions. First thing to remember is division of fractions is basically repeated subtraction. So let's take a look and unpack this word problem. There are 4 people in the Walton family, but there are only 3 waffles. So here we see the 3 waffles, and you're going to be splitting them up into 4 people. So each person's going to get one piece of this waffle here, and then one piece of this waffle here, and one piece of this waffle here. So each person gets 3 little pieces of the whole waffle, or 3/4 of a whole waffle. So they get 1/4 3 times. So now let's suppose there are 5 people and 4 waffles. So same thing. You're just going to draw your model here. You're going to draw 4 waffles. You're going to split them into, actually I should have split those into fifths, so that was wrong of me to do that. I'll change that one there. And the 5 people, I'll make 5 plates, and each person is going to get 1/5 of each waffle here. So there's 1/5 for each plate there, and they get 1/5 of this one, and 1/5 of this one, and 1/5 of this one. So each person will get 4/5 of the whole waffle. So each person gets 1/5 of a waffle, of the waffle, and they get, they get 1/5 of a waffle, and they get 4/5 of 1/5 of a waffle, of the waffle, and 4/5 of the whole waffle. So 4 divided by 5 is the same as 4 times 1/5, keep change flip, and that's 4/5. So it's a little confusing in terms of the picture, but when I draw it, each person gets 1/5 of each waffle. So 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5, you end up with 4/5 of a waffle. So I'm going to solve this problem 2 ways. It's 5 divided by 6, and that's going to be the same as, actually the easiest way to do that, they want us to do, say, 5 times. So you keep the dividend, you change the sign, and you flip the divisor. So it's going to be 5, 6 is the answer. But I like to say, writing 5 divided by 6 is the same as saying 5 divided by 6 there as a fraction. So it's 5/6. If you wanted to do a picture model here, you draw 5 things, and you divide each one into sixths, like that, and like that. Pretend I did that slowly and carefully, and you'd end up with 5 divided by 6. You'd be splitting these. Each person would get 1/6 of each one, and that would be a total of 5/6. So the answer is 5/6. The easiest way to just do the algorithm, but the picture model definitely helps you understand the problem. How can you divide 8 waffles by 9 people? Well, 8 divided by 9 is the same as 8 times 1/9, because you're taking 1/9 of each of the 8, which is going to equal 8/9. So if you had 8 waffles and 9 people, you wouldn't get a whole waffle each, you'd get 8/9 of a waffle per person. So we're looking at finding out whether this equation is true for any whole number n and d. So whole numbers are counting numbers. So if you have a number and you divide it by another whole number, it's the same as taking a part of each of those numbers. So for example, if you had 1 whole and you divide it by 2, you end up with 1 times a half, because the opposite of division is multiplication, and the opposite of 2 wholes is 1/2. So when you do the keep change flip, then you end up with n divided by d, or n divided by d, or n over d. N unit fractions 1n unit fractions 1d complete. So blank whole numbers, blank a whole number n by a whole number d. So dividing a whole number n by a whole number d is the same as dividing each of the n into d parts. blank a whole number n by a unit fraction. So I think this is multiplying here. I don't know. Multiplying a whole number n by a unit fraction d is the same as adding the unit fraction n times resulting n over d. So I think that's the answer. This problem's a little confusing. I'd have to read what the answers are, but I believe what they're saying is dividing a whole number by another whole number is the same as multiplying a whole number by its inverse here. This is a simple question, and I do like the model they used, the picture model. How many 1/8 are there in 3 holes? So if you were to take away eighths from one hole, you'd end up with 8/8. You take away eighths from another hole, that's another 8/8. And you take away eighths from this hole, that's another 8/8. So there should be 24/8 in 3 holes. So you're taking 3 divided by 1/8 is the same as 24, because you keep, you change, and you flip. There are 3/8. There are 8/8 in 3 holes, so there are 24/8. How many times can you subtract 1/8 from 3 holes? And you can subtract it 24 times. 8 times per hole. Same problem as before. How many fourths are there in 5? Well, in one hole there are 4 fourths. In another hole there are 4 fourths. And in another hole there are 4 fourths. In another hole there are 4 fourths. In another hole there are 4 fourths. So there are 4, 4, 4, 4, 4, or a total of 20 fourths in 5 holes. So there are 20 fourths in 5 holes. If you have 5 and you subtract, you divide it into fourths, you end up with 20 pieces altogether. So if you want to do the keep, change, flip, it's 5 times 4 equals 20, or 5 divided by 1/4. So keep the 5, change the sign to multiplication, and flip the divisor into, instead of 1/4, the reciprocal, 4 holes, and you end up with 20 pieces. I think I like the model the best because it shows us exactly how many pieces there are in the 5 holes. They're asking us to write a division problem. Olivia made 8 sandwiches, so if I wanted to, and I should do this, everybody should do this, you should draw your 8 sandwiches. And she cut them into thirds, so 3/3, another 3/3, another 3/3. There would be 3/3 in each sandwich. How many thirds would she have? So she has 8 divided by a third, and you have 24 thirds just by counting. If you want to do the algorithm, it's keep, change, and flip. 8 times 3 is 24. Damon has an 8-pound bag of dog food, so this whole dog food bag is 8 pounds. He feeds his cat 1/6 of a pound every day. So if I just took 1 pound here out of the bag and I split that into 6 parts, each one of these would be a day. That's 1/6 of 1, that's 1/6, that's 1/6, 6, 6, 6. So 6, 6, that would feed the cat, I guess it's cat food, not dog food. So that would feed for 6 days. Every 6 would be a day. So 1 pound would be 6 days. How many days will the dog food bag last? So 1 pound is 6 days. Another pound is another 6 days. Another pound, another pound, another pound, another pound, another pound. That's 1, 2, 3, 4, 5, 6, 7, 8 pounds. Each pound is for 6 days, so it's 8 pounds divided by 1/6 is the same as 8 times 6, which is the same as 48. So this cat food bag will last for 48 days. It's a little tricky because we're not used to dividing fractions, but if you have, let's say this is 1 whole here, and you have 1/6 of it, which would be here, that would be 1/6, and you're splitting that, you're dividing just this 6 by 3. Let me get a different color. If you're dividing this by 3, you'd split it here, and you'd end up with this part here would be 1/6 divided by 3. So 1/6 divided by 3 is the same as 1/6 times 1/3, which is the same as 1/18. Because if you look at this little portion here is 1/18 of all of them, because if we took that part, you'd have 3, 6, 9, 12, 8, 15, 18. So there'd be 18 total pieces in this, and you have one of them. So it's 1/18. Alright, they're asking us to do this. So I'm going to draw a picture. I have 3 holes divided by 7. So I have to cut each of these holes into 7 pieces. 1, 2, 3, 4, 5, 6, 7. And that would be 1/7 here. That would be 1/7 here. And that would be 1/7 here. So 3 divided by 7 is the same as 3/7, because there's 3 parts out of 7. If you want to do the algorithm, it's 3, keep the 3, change the sign to multiplication, and flip the divisor. So it's 3 holes times 1/7, 3/7. Like we did before, if I have a whole number 0 to 1, but I only have 1/3 of it right here, and I divide that third into 5 parts, I end up with 1 part here out of a total of 15 parts, so that's going to be 1/15 of the total. The algorithm turns into 1/3, keep that, times 1/5, so change that, flip that, equals 1 out of 15. So this piece represents 1 out of 15 total pieces in the whole.